Hello, my name is Martin Potruschek. Welcome to this Beckhoff webinar about K-bus terminals and how to use them. In the next minutes we will have a look into the features and technical data of the K-bus system of Beckhoff, and then we will see the three ways how to get access to the parameters of the K-bus terminals over the KS2000 software, PLC and TwinCAT engineering. Just for remembering how the K-bus system was invented in the mid of 90s, Beckhoff presented this intelligent bus terminal system because in that time there was a central PLC common with central IOs and a lot of wiring and copper into the decentralized sensors actors. So you need a lot of terminal blocks, and the idea of Beckhoff was then 1995 to make their more intelligent into the 6mm terminal row and to create here this intelligent bus terminal system. And you need some communication between these intelligent devices. This is done over these contacts here you see on the right side. So all terminals can transport data, read and write data over this serial communication communication interface inside of the terminals. How is the system working? You have always a head station, the bus coupler, which is not programmable, and you have sometime a bus controller, BC, BX, which can make local PLC programming, so you can have there some additional code inside of the head station. What is the main point? With the K-bus system you have always two levels of communication. You have a field bus on the left side, Profibus, Interbus, and you have the terminal bus, the K-bus, inside of the terminals. So that makes the diagnosis a little bit complex because you not really have direct access to the slaves from the field bus side. Inside of the K-bus terminals, especially when they are analog terminals, they have a lot of registers where you are interested in. For example, here in register 19 and 20, the manufacturer scaling in offset and gain. And such values here, as you see it here, are stored inside of these registers and should be manipulated in some cases to change the behavior of the terminals. Have in mind that some of them are password protected. The password 1235 is written in the documentation, and it's just a protection that it's not, the values are changed without willing it really. So inside of these analog terminals you have a lot of these registers, and we are interested to get access to it. Just some technical data about this K-bus system of Beckhoff. You have maximum of 256 digital input-output devices or 128 analog devices, and each of them can transport up to 12 bytes of data. The complex devices also have an identification, so you can scan it. Normally you have 64 devices after a coupler. With K-bus extension you can run up to 250 terminals. Every device can support up to 4 channels. If a terminal has more channels, you need several bus ICs inside, or you have a time multiplexing behavior like in the safety devices. But normally you as a customer, you will not see it because it's all solved by the coupler and you only see the finalized process data of the device. Every channel can have up to 64 registers, so that are the settings values or raw data values. When more are needed, then a second page must be opened in the side of the terminal, of course, so you as a customer, you have nothing to do with that. And the last part here, the K-bus free run cycle time depends on the number of terminals and kind of terminals, 1 or 2 milliseconds to run the communication between all terminals. When you power on such a bus coupler or a bus controller, then there is a lot of self-test inside and a terminal test, and you will get the result by error code over the field bus, or you see the LED blinking code on top of the coupler outside. Sometimes you need a reset of the station. For example, when you have when you pull out some terminal, then you can set in the coupler that there is a self-reset after the car bus power down, or you do the reset by the PLC by a command for yourself. And so let's come to the technical parts. This is just for information to you, because normally as a TwinCAT customer or in a TwinCAT application, you do not handle this bit and byte orientated data. This is just for information to you. It's outside from the documentation. When you want to get in contact with another field buses and not TwinCAT software, then you have to know how the process data inside of the coupler and the terminal is built up. And this is shown here in the documentation. First are the outputs, the byte orientated and the bit orientated, and the next in the memory is the input data, byte orientated and bit orientated. Same as in the coupler is here in the terminal. You see the process data, 2 output bytes and a control byte, and 2 input bytes and the status byte, which is the maximum process data that a terminal can have on the K-bus system, together with the other 64 registers that describe the behavior of the analog inputs. But as I said, as a TwinCAT customer, you are not deeply involved with that points, because in TwinCAT, you see it here, it's very easy also to use KL terminals. You can scan it, you can edit, you can link the variables, the data in and data out, very easy, so you have nothing to do with the internal memory addresses inside of coupler or terminals. Yeah, and here in this page you see that the process data, the data in of this thermocouple terminal is linked with the PLC, but you see also you have here channel 1, 2, 3, 4, but you have nothing to parameterize. So how can we get access to the registers for an acyclic behavior change inside of the terminal? And so we have there 3 ways how to get into access with the registers inside of the terminal. First point is the KS2000 software over serial USB cable or ADS. You can connect from the runtime system to PLC over ADS, and you can change the registers from the TwinCAT engineering by register address. So the way is always the same. You have the coupler between you and the terminal, and you can use it as an ADS gateway, or you use the COE tables in the coupler when it's an EtherCAT device. So let's check before the first way, the KS2000 software. You have to set up the communication channel. In that example here it's serial via COM. Then you can make a communication test with the coupler over the USB cable. In the end, then you can make a login, and then you see the coupler station with its terminals. You see the online data, the input data that are coming into the systems. And on the left side, you see here the hardware tree, where the coupler and all terminals are set up in such a hardware configuration. We want to have a focus on the terminals, on the complex terminals. You see here that the thermocouple terminal KL3314 has registers, settings, and process data. The register table you see here, it's a big table with decimal and hexadecimal values. What each register means you can read in the documentation, if there are the raw data or the calibration data or the name of the device or some other behavior settings. It's not so easy to use. You can here make write and read access, but more easier to use is here the settings tab inside of the KS2000, where for each terminal is a special mask available where you can set the function. And a third part is here available for the process data of the terminal. In that case, it's the thermocouple device, and you see here the temperature, which is measured with 24.9 degree, and you see directly here what is happening with the analog input devices out from the KS2000 software. The second way we have to access to the registers is by PLC communication. So when you are not in the engineering time, but when you are on the machine is running and PLC is controlling everything, then maybe you want to change something in the terminals, change some registers, then you can do this over this register communication. This is also described in the documentation of terminals and bus couplers, and when you use the control bit 7, so that means the 7th bit in the control byte, then the terminal knows that there is a special register communication needed or required from the master. You can program this by yourself, but you can also use the TC2 coupler lib where these function blocks for reading and writing registers are available. The third way that is possible to have access to the registers is while engineering time, when you use TwinCAT to go on the coupler, make a right click by mouse and say register access, and then you have directed the hexadecimal tables on your desk when you are connected with the coupler and TwinCAT is in free run or run. So these are the three ways that you have available to change something in the K-bus terminals. And all of them are together completed inside of our EtherCAT couplers, because we have couplers that have on the left side EtherCAT, on the right side they have K-bus connection. And so when you want to go out from the PLC, you use the ADS router and it goes over the EtherCAT master in the one way over the ADS gateway into the terminals. And the another point is the internal COE tables of the coupler. Everything this is described in the documentation of the BK1120, and also there is an example program available to to change the registers in the K-bus terminals over this EtherCAT bus coupler. So you see the K-bus is a quite old system, mid of the 90s, so it has the features from that time, but you also see in the EtherCAT that has Beckhoff invented in 2003, a lot of these features are much more improved than to the K-bus. So we have a very exquisite slave identity inside of the field bus. The coupler is in EtherCAT a very simple one. We have a very high speed compared to the K-bus with the slow baud rate. There is in K-bus no synchronization available, but in EtherCAT of course it is with distributed clocks. We have much more process data that are possible to transport per slave. Up to 65 kilobyte are possible to transport in EtherCAT according to the specification. Diagnosis is very good fulfilled in EtherCAT devices. In K-bus you see it's the two-stage level with the terminal bus and the field bus, and in the end the access to the settings. In K-bus it's done over the coupler into the registers. In EtherCAT it's done directly over ADS into the COE of the terminal. So you see the history of EtherCAT is based also on this K-bus communication, and a lot of features of that are much more improved in this EtherCAT system. You see all this information, you get this information here from our website in the documentations of the bus terminals and the couplers, but also of course here in the information system. You can install it on your system or see it online, and you get there a lot of information how to make this register communication, and especially then also select the right analog input terminal that you want to use. So then, thank you for your attention. I hope this webinar is a little bit helpful for going into this K-bus communication, and maybe we see us in the next webinar. Thank you.